Going on to lesson 2 of chapter 1. And keep in mind, we are assuming that you've watched the Flip Classroom video lesson on this topic before you do the practice. And then, of course, you will do the certify that will earn you points toward your end of term grade. And again, pause frequently. Topic, or question 1, I should say, is convert this to standard notation. So let's write it big here. 5.21. And it's 10 to the 4th power. That means we have to add 4 decimal places to the right. So I have to add 2 zeros. And now I move from where the decimal place is over 4 places. And then that is the notation in standard notation. In fact, let's just clean it up here a little bit. It takes time to do these things here. Now, while we're here to practice, let's put this in scientific notation. Remember, scientific notation is some number between 1 and 10 times some power of 10. So we have to, and our decimal place is here. So to put this as a number between 1 and 10, I'm going to move it 1, 2, 3, 4. And I get now 5.21. And my exponent, since I moved it 4 places, is 4. So theoretically, you ought to be able to go back and forth. Okay, let's go on. Now in number 2, the surface area of a box, not the volume, the surface area. Now they're not giving us a formula, so we have to make up our own formula. Well, notice we have a top and a bottom. That's going to be 2 length times width. That'll give us our top and bottom. Now we have 2 sides, which are going to give us 2 times width times height. Now we have a front and a back, which is going to give us 2 length times height. Okay, so now on your own, keeping in mind that the length is 25, the width is 7, and the height is 10, do some substitution here, and let's see how far you can go on your own, and I'll do it on my end as well. So what I did is I substituted our values. The length is 25, the width is 7, and then 7 times the height, which is 10, and then the length times the height, which is, I should say, height is 10. So I get these 175, 70, 250 that I have to double. And when I added them all up, I got 990. Again, this one was a little tedious because you had all this calculation to do, but hopefully you're following what we're doing. Now in example 3, they're asking us to rationalize the denominator. Well, here we're going to multiply the denominator by 1, or the fraction by 1, but what form would rationalize the denominator? What form of 1? And as we mentioned, it's often whatever's in the denominator, square root of 6 over the square root of 6. Our numerator then becomes x, the square root of 6, and our denominator is the square root of 36, which is 6. We've gone from an irrational denominator to a rational one. All right, now for number 4, if you rewrite this, it's a negative 1 times 6 to the 4th power. And what is 6 to the 4th power? Well, that's 1,296. That would be this part. But now we have to multiply it by that negative 1. Or when that negative is out in front like this becomes a negative. So keep in mind when looking at exponents, the exponent only refers to what is immediate to the left of it. Now, in order to have the negative included, we would have had to have the parenthesis like so. But when that parenthesis doesn't include a negative, the negative is on the outside. This is the tricky part. You need to remember that. Now, in this example, they're asking us to simplify this expression. Now, we could put it in our calculator and get a value for it, but then it wouldn't be an exact answer. So what are we looking for here? Well, we can convert it from its radical form to its fractional exponential form, which is this. Remember, we remove the radical sign. This becomes the denominator of our exponential fraction, and the 1, which is the power to which every number is raised, becomes the numerator. Now, another way of looking at this is we can do this. The base is 4, the exponent is 1/2, and notice if we multiply these exponents here, we get 4 to the 1/4 power. So this is valid. Now, what is 4 to the 1/2 power? Well, that's the square root of 4. And what is the square root of 4? The square root of 4 is 2. So inside here, we can substitute, and I'll erase it. Just wanted to show you where it came from, with a 2. Now we have 2 to the 1/2 power, and anything to the 1/2 power is the square root of something. So this simplifies to the square root of 2. Now, if you were to approximate that, that is 1.414, and it goes on. But I think they're asking here to simplify. Again, you have to know what they're asking. And again, that tutorial bar is always available for you in the practice. Again, pause, try these on your own, or follow along once you finish or right now. All right, I'm going to get rid of the exponents outside of the parentheses here. So let's start. X to the negative 12. And I'll keep my parenthesis anyway for now. So this is x to the second times a negative 4, which then will become x to the negative 8. And this is y to the second to the negative 4. This is going to be y to the negative 8. Now, I don't really need to have a parenthesis there, so I'm going to take it away. All right, that's my numerator. Now let's simplify the denominator here. Now it's 4 raised to the 4th power. So what is that? Well, that's 256. And then it's a negative 4 times 4. So this is x to the negative 16. And then we just have y to the negative 10. Okay, we're going to now group like terms in a sense. Do this multiplication by adding exponents. These are all intermediate steps. X to the negative 20, y to the negative 8, over 256, and that's x to the negative 16, y to the negative 10. Looking at the wrong line here. There it is. Okay, check your work. So I want my answer to be positive. So I know the 256 is going to stay there. Now, if I bring the y to the negative 10 up, crossing this division bar, the sign of the exponent changes, becomes positive 10. This is going to leave me with y to the second in the numerator. I'm going to take this x to the negative 20, bring it down where it becomes x to a positive 20, and I'm left now with x to the fourth. And there is your answer. So it looked daunting, but again, step by step, following the protocol. Number, do we have a 7? I guess we don't have a 7. So we're jumping to 8. We're just trying to note these. Convert this now to scientific notation. Remember, we're going to need a number between 1 and 10 times some power of 10 raised to an exponent. Now, if it's a small number, we know it's going to be a negative exponent here. If it's a large number, it's positive exponents. And we know this answer is going to be negative, so I'm going to put my negative out there. Now I have to move my decimal place to make this a number between 1 and 10. So let's do it together. 1, 2, 3, 4. So I know this is going to be a negative 4. And it's 3.69. 3.69. And I've converted it now to scientific notation from standard notation. All right, let's jump to number 9. This is pretty straightforward. As long as that negative sign is not under the radical sign, this would not be a real number. But out here, it's just going to be negative. Square root of 100 is 10. No, it's not this. Don't make that error. All right. Going on to number 10 now. We need to expand this. This is the powers rule. So a negative 4 squared is 16. X to the third raised to the second is going to be multiplication x to the sixth. Now, y to the negative 1 squared is y to the negative 2, but they want positive values. So we have to move that y to the negative 2 up to the numerator where it changes its sign, and then there's the answer to number 10. All right, let's pause, raise it up. Now, for example, 11, I'm a tad surprised they're not giving us the formula for this. We have to make our own formula. So here we have a trapezoid for an edge. And the formula for a trapezoid for area is area equals 1/2 the height, which is this, times the base and the top base, the sum of that. And then we have to find and add to that its length here. So we add an L there. Okay, so take this. I've put the values here. See what you can come up with. Now I've converted the 1/2 to 0.5. Our height is 2. So in a sense, 1/2 of 2, this is just going to be a 1 here, times 22. times 24, which I get as 528. And what is this, meters? Yeah, meters squared. There we go. And once again, this is just a sampling. And having the background of our flipped classroom video hopefully gives you the background to do these. So if I were to solve this, I would put this as a positive exponent. And I would get then 1 over a negative 8/27. And then this is to the 2/3 power. Okay, now I will convert this denominator to its radical form. So this then becomes the 3rd root of a negative 8/27. And this whole thing then is going to be to the 2nd power. Okay, so now 3rd root, let's just simplify it a little bit more. The 3rd root of a negative 8 is 2, negative 2, over the cube root of 27, which is 3. That's now going to be raised to the 2nd power. So this then becomes 1 over negative 2 squared is 4/9. So we have this, still not finished. And I don't know if you recall that this is sort of like 1 divided by 4/9 gets converted to 1 times the reciprocal of 4/9 when we change that division sign to multiplication, 9/4. And 1 times 9/4 is 9/4. And that is what the answer to number 12 was. This was somewhat tedious, lots of steps. Remember, you can always go back and watch these again. It's the nice thing about it. Now for this, when I first looked at it, I realized we had to do some modification here. This is good. This is simplified already. We don't need a radical sign here. Oop, my eraser. There we go. 3y, the square root of 3y. Because if I divide this by 3, and let me just do it here, I get 81 y squared and 3y. Simplifying this by taking out the greatest perfect squares out of here, factors. So these are now factors, 81 times 3. Well, this is 9y, the square root of 3y, plus 3y, the square root of 3y. Now when the radical portion is the same, we just add up our, in a sense, coefficients, which gives us 12y, the square root of 3y. Okay, that completes this. Again, it's only a selection of some of the practice as you get ready to do the certify.